Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of the electronic circuit where we are discussing the various components used in the electronic circuit. In the today's lecture we discuss about one of the important component, that is the light based, which is a LED. LED we have discussed, but now we will discuss the OLED, that is the Organic Light-emitting Diodes. In the recent years, we are seeing that nowadays the LED replaced with the OLED because of its performance and its brightness and its application in many devices. So, by keeping in mind, we discuss the what is OLED and what are the invention behind it, what principle we use in the construction of OLED, and apart from this we discuss its advantages and types of OLED we discuss in this lecture. Now we will start with that. This OLED means Organic Light-emitting Diode, that are colored, and this is the light source, and we have having the white OLEDs as well as we have the colored light sources in this OLED, and that used for the smartphone, TV screens as well as the panels for the lighting application nowadays. Over the past 25 years, the research and development of OLEDs became rapidly expanding field in academia and the industry, because OLED offers a new efficient and sustainable method for lighting and display technologies, and are on the rise of the rise of the previous technology nowadays which is used in the market, especially in the display industry. OLED have moved into focus in recent years, as OLED displays offer the some features that grant them superior properties over the well-established technologies. Like we see that in the daily life we use this OLED in the liquid crystal display. LCDs we use nowadays in our homes, LCD as well as in the computer system. In the offices we use LCD. So these LCD made up from the OLED. For example, OLED devices do not require a backlight system in comparison to the LCD. So LCD replaced with the OLED devices because there is no requirement of the backlight in the development of OLED. So this is not only the energy efficient, as an inactive OLED element does not produce light or consume power, but also allows for a true black and thinner and lighter display to the user. So OLED have the many applications, and on the basis of that we use these OLED for the display. And because of this OLED, we can improve the resolution, we can see the wider viewing angle, we can have the high contrast color, we are having a faster response time and the possibility to realize transparent displays by using this technology. So OLED technology is based on the phenomena that certain organic material, as OLED, Organic Light-emitting Diode, here we are using the organic material. So OLED technology is based on the phenomena that certain organic material emit light when fed by a electric current. When we use the organic material for lighting a system passing the electric current, then it is called the OLED. So OLED technologies makes it possible to manufacture ultra flat, very bright and power saving OLED devices, in which we can have the televisions, we can have the computer screen, we can have the mobile phones, etc. Display units in the various devices. So windows that could be used as a light sources at night, and large scale organic solar cells also the part of this OLED. In contrast to the regular light emitting diode, that is LED, the emissive electroluminescent layer of an OLED consists of thin layer of the organic material. Organic material are required for the development, and the layer we use on the LED. What makes OLEDs so attractive is that they do not require a backlight to function and therefore require less power to operate. Very less power as compared to the LED. Since they are thinner than the comparable LEDs, they can print it out almost any substrate. So we use this OLED. Now, what is OLED? How we define or how we can introduce the OLED? How we give the introduction of the OLED? OLED stands for the Organic Light-emitting Diode. That is a solid state. OLED are easier to fabricate and hence are replacing CRT or LED display due to its flexibility. Here the name suggests that we are using the organic material, and that is also a solid state material we use for development of OLED. And this OLED developed is very flexible as compared to the CRT and LED. And it is an electronic device made by placing series of the organic thin film between the two conductors. How we prepare this electronic device? By placing the series of organic thin films. So we take the material, organic material, and we prepare a thin film on of this material, and then we connect it in the series and we put it in between the two conductors, and then when the light pass through it, then we can get the output in the form of the light. So a bright light is emitted when the electric current is being applied to the conductors. So OLED consists of the two thin films organic materials and two conductors, and the electric current is applied to get the brighter light or to emit the LED. And they are very thin film organic semiconductor we can take, and these are the light emitting diodes. And these are light emitting devices. OLED works on the same principle of the electroluminescence, where we are having anode is a transparent and made of the indium tin oxide. Electroluminous, we require the anode and cathode, and the next is a cathode, which is the reflective and made of any metal. We can say that anode is the transparent and made of the indium tin oxide, where cathode is reflective and made of metal. When an external potential is applied across the electrodes, here we are having the cathode and anode, and when we apply the external potential and the negative charges, we applied the external potential is applied across the electrode, then we can have the positive and negative charges are injected. So these electrons and holes shift inside the material. Then when it shifts inside the material, then the recombination takes place, and then this recombine to form excitons and consecutively emit photons, and in this manner we can get the light. So one, we have a anode which is the transparent. Second, we have a cathode which is reflective and are made of the metal. Now when we apply the external potential across these electrode, positive and negative charges are injected simultaneously, and these electron and holes shift inside the metal, recombine to form excitons, and consecutively we can get the light in the form of the photon, means photons are ejected. What is the history behind the OLED? OLED or the OLED is a technology that has been around for the several decades, organic light emitting diode. In the early days of the OLED technology, the focus was on developing the simple low-cost displays. So first OLED was created in the late 1980s by the researcher Eastman Kodak. Over the time, OLED have evolved into a versatile and highly sought after technology and wide range of the application in the display and lighting industry. So we can see on the screen that in 1987 first OLED prototype is created by the researcher Kodak, and 1991 first commercial OLED product, which is of the red color display, was produced by the Kodak itself. In 1998 first blue OLED is produced, opening up the possibility for the full color OLED displays. In 2002 13-inch prototype OLED for the TV that was introduced by the Samsung. And in 2007 the first OLED smartphone was developed, that was given by the Sony Ericsson. And in 2010 the first OLED television, and that was introduced by the LG. And 2014 the first curved OLED TV introduced by the Samsung. And in 17 foldable, we can fold the smartphone, as you have seen in many phones that we can fold the smartphone, that was given by the Samsung Galaxy in 2017. In this manner the development of the OLED has introduced day by day and year by year. So one of the most exciting development of OLED technology has been introduction of the flexible and transparent displays. It is one of the advantage of OLED that we can get the flexible and transparent displays, and these displays have the potential to revolutionize the way we interact with displays and make them more impressive and the user friendly. So if we use OLED, then we can make it more flexible, more touchable and more easily usable. Whereas we see that Samsung has already introduced a line foldable smartphone, and that is based upon the OLED technology, while LG Display has developed an flexible OLED displays and then can rolled up like a newspaper that we can use. If we talk about the history of the OLED, one of the rapid evaluation and the innovation is then the red displays to the latest in curved and foldable displays. OLED technology has become a long way in the short amount of the time. So by using this technology with its bright, vivid display, fast response time and high contrast ratio, OLED technology is set to play a major role in display and lighting the industry and year to come. What is the principle behind the OLED? OLED devices can be divided into the injection of the electrons and holes, as there is a combination of the holes and electrons. So the basic principle of light emitting process of OLED devices can be divided into the injection of the electrons and holes, transport of the electrons and holes, third is the recombination of the electrons and holes, and fourth one is the de-excitation light of the excitons. Especially you see on the screen that here we are having the OLED lightning process. The principle is here. You see on the screen we are having a metal cathode, and you see also there is a anode. Right hand side you see metal cathode, and right hand side we are having a anode. That means we are having a two emit organic material in between this cathode and anode. In left hand side you see that is a ET electron transfer layer and the organic emitters, and there is a hit hole injection layer where we put the injection of the holes and electrons takes place, and you see on the bottom the light is we will form. There is a de-excitation of the photons and we can get the light output. So this is the basic arrangement of the OLED, where we are having a cathode, anode and the two organic metal in between cathode and anode, and the light output from the transparent metallic oxide. Now the injection of the electrons and holes, the electrons first what happened, what is the first step is for development of the light, or how we can get the light. The first step is the injection of the electron and holes. The electrons in the cathode and the holes in the anode will move to the light emitting layer of the devices under under the drive of an external driving voltage. Means here we put the voltage, and then there is a movement of electron from the cathode and electron holes from the anode. During the process of moving to the light emitting layer of the devices, the device contains an electron injection layer and hole injection layer in between that. The electrons and holes must first overcome the energy barrier between the cathode and the electron injection layer and the anode and the hole injection layer. Then what happened? Move to the electron transport layer and the hole transport layer to the devices. Now here, through this electron injection layer and the hole injection layer, the efficiency and the lifetime of the devices increases. The mechanism of the electron injection in OLED devices is still under the constant research, and the most of the common used mechanism are tunneling effect and the interface dipole mechanism are used in this. The second process is the transport of the electron and holes. Now, as there is injection of the electrons and holes, now there is a transport of the electron and holes. Driven by the external driving voltage, now the electrons from the cathode and holes from the anode will move to the electron transport layer and the hole transport layer of the device respectively. Now the electron transport layer and the hole transport layer will move the electrons and holes to the device respectively at the interference of the light emitting layer. In the third step, there is a recombination of the electron and holes. So when the number of holes and electrons at the interface of the light emitting layer of the device reaches a certain number, so electron and holes will recombine and generate excitons in the light emitting layer. So as this reach in the light, at the same time the electron transport layer and the hole transport layer will block the holes from the anode and electrons from the cathode at the interface of the light emitting layer of the devices, so that the electron and holes at the interface of the light emitting layer of the devices are accumulated, and there is a combination of the recombination of the electron and hole. In the fourth step, there is a de-excitation light of the excitons. As we get the excitons, so the excitons generated in the light emitting layer will activate the organic molecule in the light emitting layer of the devices. That coating has been done on the lower part of the device, so which in turn causes the electrons in the outermost layer of the organic molecule to the transition from the ground state to the excited state, and in this manner the electrons in the excited state are extremely unstable and they will move to the ground state during the transition. So energy is released, and this energy is released in the form of the light during the transition, and the device emit lights. So in this manner we can get the light from the arrangement. Now how an OLED emit light? There is a step, as we discussed, that OLED light up, we simply attach a voltage potential difference across the anode and cathode. We attach the voltage or a potential difference across the anode and cathode. As the electricity starts to flow, the cathode receives the electrons from the power source and anode loses them and it receives the holes. If prefer, then we have a situation where the added electrons are making the emissive layer negative charge layer, and similar to the N-type layer in the junction diode, while the conductive layer is becoming positively charged as holes are there and electrons are there. So positive holes are much more mobile than the negative electrons. So they jump across the boundary from the conductive layer to the emissive layer. So when the hole meets the electron, means there is a recombination of the holes and electron, the two things cancel out and release a brief burst of energy in the form of particle of the light, that is the photon. In other words, this process is called the recombination. In case of the recombination, there is a release of the brief burst of the energy, and this process is called the recombination, and because it's happening many times is in a second, so it produces the continuous light as long as the current keeps flowing in the circuit, and OLED produces the light. We can make OLED produce colored light also by adding a color filter into our plastic sandwich just beneath the glass or the plastic top or the bottom layer. As color we required, we put that color filter. If we put thousands of red, green and blue OLEDs next to the one another and switch them on and off independently, they will work like a pixels in the conventional LCD screen, and we can produce the complex high resolution colored pictures. As you see on the screen, that this is the method how we will get the light. You see here we are having a cathode, and at the bottom we have an anode. We have the two layer, one is a conductive layer and second is the emissive layer. Now the cathode generate the electrons, anode generate the holes, then there is a recombination region, after that there is emission, where the emission takes place. The emission takes place in the form of the photon and it generates the light. So we will continue further this lecture about types of OLED and applications of OLED. Thank you very much.